there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 2 in the statistics unit, displaying a data distribution. Some say data, some say data. Data, data, tomato, tomato. Okay, I say data. Classwork, example 1, heart rate. Mia, a 6th grader at Roosevelt Middle School, was thinking about joining the middle school track team. She read that Olympic athletes have lower resting heart rates than most people. She wondered about her own heart rate and how it would compare to other students. Mia was interested in investigating the statistical question, what are the heart rates of students in my 6th grade class? So there is the question. So heart rates would be so many beats per minute. Those are numbers, so this is numerical data. Okay, heart rates are expressed as beats per minute or BPM. Mia knew her resting heart rate was 80 beats per minute. She asked her teacher if she could collect the heart rates of the other students in her class. With the teacher's help, the other 6th graders in her class found their heart rates and reported them to Mia. The following numbers are resting heart rates in beats per minute for the 22 other students in Mia's class. And here they are, 89, 90, 79, and so forth, all the way out. They're all pretty similar. So exercise 1 through 10, there's a bunch of questions here, and we'll just move this to here so we see the data. What was the heart rate for the student with the lowest heart rate? Okay, so I'm looking 80, 80, 80, 80, 90, 70. There's a 70, and I think that's the only 70. 8, 8, 8, 8, 8. So you go all the way through all your data looking for numbers, and the lowest heart rate was 79 beats per minute. 2. What was the heart rate for the student with the highest heart rate? Okay, here's a 90, and I don't think I saw any other 90s. Everyone else was in the 80s, so that is it. 90 beats per minute. How many students had a heart rate greater than 86? So now I'm going to mark the ones that are greater than 86. There's 1, 2, 3. Greater than 86 does not equal 86, so I will not count the 86. Greater than is just this, not equal. So I'm not going to count 86. 88, 84, 81, 88, 85, 83, 83, 86, 82, 83, 86, 82, 84. So there are 1, 2, 3, 4, 5. 5 students at a heart rate greater than 86 BPM. 4. What fraction of students has a heart rate less than 82? So now let me erase this. And remember, less than does not include equal. So less than, the symbol for less than. Okay. Oh, look at me. That is less than here. Wow. My apologies. Greater than. Less than. All right. Ooh. Okay. Which fraction of students had a heart rate less than 82 beats per minute? 89, 87, 85, 84, 90, 79 is less than 82. 83, 85, 86, 88, 84, 81 is less than 82. 88, 85, 83, 83, 86. 82 is equal, that's not less. 83, 86, 82, 84. There were 2 out of the 22 students. So if I just move this up a little, remember 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 2 out of 22 had a heart rate of less than 82 beats per minute. Those are both even numbers, so I can reduce them. 1 out of 11 if you want to reduce. Okay. What heart rate occurred most often? Okay, most often, that is called mode. The one that occurred most often. So now I'm going to take a look, and we will 89, 87, 85, 84. Nothing's repeated yet. 90, no 90s yet. 79, 83, 85. Here's an 85. 85. 86, 88, 88. Here's an 88. Here's an 88. Here's another 85. I'll circle 83s. And I'm leading up to something here. There's a reason why we're doing this, and this is really difficult the way I'm doing it, but there is a better way. Where's 85? No more 85s, 85s, 85. Okay, any other 83s? There's another 83 right here. So there's 1, 2, 3, 4 83s, 2 88s, 3 86s, a couple of 82s, an 81, a 79. So it looks like 83 occurred 4 times. So the one that occurred most often was 83 beats per minute. It occurred 4 times. Okay. Number 6, what heart rate describes the center of the data? Okay. Well, in order to do center of the data, we have to put these numbers in numerical order. So I am going to do that right below here. And the lowest number is 79. So let me erase this. And I will cross them out as I write them. So here's 79 dot. Is there any 80s? I don't see any 80s. Here's an 81. I will put that next. I don't see any. Here's an 82. Here's an 82. 83. 1, 2, 3, 4 83s. I'll write that 4 times. 84, 84, 84 3 times. 85, 85, 85 3 times. 86, 86, 86, 87, 88, 88, 89, and 90. And they're all crossed out. Now, if I did this before to answer question 5, what one occurred the most, then I'd see that there were 4 83s right here, 3 84s, 3 85s, 3 86s, 187s, 2 88s, 189, 190, 2 82s, an 81, and a 79. So when we put our numbers in order from least to greatest, it's easier to determine which values occur more. Now, when we talk about middle of the date road, we're talking about the center of the data. So if there's 22, 11 is half of 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right here. So my middle is somewhere around 84 or 85. So 84, 84 or 85 could be our center. Okay. Number 7, what heart rates are the most unusual heart rates? Some students' heart rates that were unusual in this way were quite a bit higher or a bit lower than most of the students' heart rates. What were those rates? So if we go back and look, 79 and 81 were pretty low compared to 84, 85. And 89 and 90, I would say, were pretty high. Okay. So 79 was low, and 90 was high. So let's just go with the highs and the lows. If me as teacher asked what the typical heart rate is for 6th grades in the class, what would you tell me as teacher? Okay, and what I would say would be most were between 82 and 86. The most common was 83. Number 9. Remember that Mia's heart rate was 80. Add a dot for Maria's heart rate to the dot plot in example 1. Okay. What dot plot in example 1? Do you see a dot plot in example 1? I do not see a dot plot for example 1. Okay, so let's create one. Okay, so now where could I do this? I will do it, might as well do it right here. So let me get my ruler. Let me pause the video and I'll draw the segments and then put the dots in after. Okay, so here's my number line. Now we're going to create a dot plot for these values. So I got to go back and forth here. 79, 81, and 2 82s. So to put a dot on the dot plot, 79 would be here. 81 would be right here. There were 2 82s. So I put one dot here and one dot here. Okay. Let me go back and look. Now we're up to 82. Then we have 4 83s and 3 84s. So 4 83s. 1, 2, 3, 4. 3 84s. Okay. And then when I go back, 85 there were 3, 86 there were 3. So 85 I'll put 1, 2, 3. 86 I'll put 1, 2, 3. All right. 87, 2 88s. Okay. 87, 88 occurred twice. 89 and 90. So 1 here and 1 here. So there's our dot plot. And now we want to add a dot for Mia's heart rate to the dot plot. And hers was 80. So hers would be here, and I'll do that in red. Okay, so there's Mia's class in black, and she is in red. Okay, so number 10. How does Mia's heart rate compare with the heart rate of the other students in the class? Well, she is right here. So her heart rate is slower than all but one of her classmates. Okay, example 2, seeing the spread in dot plots. So Mia's class collected data to answer several other questions about her class. After collecting the data, they drew dot plots of their findings. One student collected data to answer the question, how many textbooks are in the desks or lockers of 6th graders? She made the following dot plot, now including her data. So there were 4 students who had 5 books, 6 students, or there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think. 11. There were 11 students that had 6 books, 4 students had 5 books, 4 students had 7 books, and 3 students had 8 books. Okay. Another student in Mia's class wanted to ask the question, how tall are the 6th graders in our class? This dot plot shows the heights of the 6th graders in Mia's class, not including the datum for the student conducting the survey. Okay. Datum is singular for data, so that does not include the height of the person that did the survey is what that is. So there it is. We had 1 student who was 49 inches tall, 2 that were 50, 151, 152, and so on. Okay. Exercise 11 through 14. Below are 4 statistical questions and 4 different dot plots of data collected to answer these questions. Match each statistical question with the appropriate dot plot and explain each choice. Okay, before I go on with this though, let's go back and look at these. Okay. So when the students thought about this question, many said that they all had about the same number of books in their desks since they are all taking the same subjects in school. So we're looking at this diagram here. But it turned out to be that there were some students who had several more books in their lockers or desks. So the class noticed that the graph was not very spread out since there was only 4 different answers the students gave. So the outcomes were between 5 and 8. So that means the spread was very little, okay, between 5 and 8. Actually between 6 and 9, because between is not including the endpoints. But then another student wanted to ask a question about how tall 6th graders in the class were. And this is the dot plot here. Okay, this one's more spread out. It went from 49 all the way up to 66. So if I take 66 minus 49, that's a difference of 17. Or if I take 8 minus 5, that's only a difference of 3. So this spread was less than the height spread. Okay, and that's what we're talking about when we talk about spread. Right, distance from the smallest number to the largest in our set of data. Okay, so now we have these questions. Statistical questions. What are the ages of 4th graders in our school? Okay. Okay, I zoomed out to 100% so we can see the questions and the dot plots that we need to match. So ages of 4th graders in our school. Well, when you're thinking about 4th graders, you're usually 5 or 6 when you start school, so you should be 9 or 10 years old when you are in 4th grade. You're not going to have a baby that's just born in 4th grade. You are not going to have a 1-year-old in 4th grade, so that doesn't make sense. And here's a 1-year-old, that doesn't make sense. And I would hope that you are beyond the 4th grade by the time you get to be 58 years old. So I would have to say that dot plot A is the answer to question 11. Okay, and I'm not going to write the explanation, I just explained it verbally. Okay, 2 or 12. What are the heights of the players on the 8th grade boys basketball team? Okay, so have a height of 0, so this is gone. We're not going to have a height of 0, that's not possible. Okay, we aren't going to have a height of 1. But these must be in inches. 58 inches, 60 inches is 5 feet, 74 inches way out here is over 6 feet tall. 72 is 6 feet, and basketball players are usually tall. Okay, so I would say dot plot D was the answer to question 12. Number 13. How many hours of TV do 6th graders in our class watch on a school night? Okay, some don't watch any. Some may watch 8. That makes sense. But if I come down here, there's nobody who doesn't watch any TV shows, and I'm sure there's people who watch more than 3 TV shows or hours on a school night. So if you get home at 4 in the afternoon, I'm sure there's plenty of kids who watch TV beyond 7 o'clock, 8 o'clock, 9 o'clock, you start adding up hours. Okay, so I would assume that dot plot B was the number of hours watching TV after school. Okay, and then finally, how many different languages do students in our class speak? Well, it wouldn't make sense that there were 0 because then you wouldn't speak any languages. You wouldn't be in the 4th grade. You would have to be somewhere else. So most people only speak 1 language in the United States, so there's a 1. But then you get outside of the United States and you start talking about people who speak English plus the language of their country. English is very common, but not always the second language. And oftentimes you can have students with 3 languages. So that would be the answer to number 14. So my answers are, if I were to write these, dot plot A, dot plot D, dot plot B, dot plot C. Next page. Oh, that is the end of lesson 2. Go do your problem set.